Welcome to the next video of the chapter Electricity. In this video, let us understand the meaning of electric potential difference. It is voltage, its unit, formula, properties, measurement and application. But before that, let's recall what we learned in the previous video. We had understood that electricity is the flow of charges through a conductor or the number of charges that flow through a conductor in a unit time. So, if you want to represent electricity in a formula, we can represent it as I is equal to Q by T or NE by T. The SI unit of current is ampere. The charge of an electron is minus 1.6 into 10 raised to minus 19 coulomb, where 1 coulomb charge is the charge of 6.25 into 10 raised to 18 electrons. We also learnt that electric current is measured by an ammeter. Now let's think. What makes an electric charge to flow through the conductor from one point to another point? Let us consider the analogy of flow of water. If you arrange two beakers like this, in which case do you think the water will start to flow? It's very easy to guess, right? We know that water will always flow from a higher level to a lower level. If the levels of water are equal, then there is no flow of water. When there is a difference in the height, there is a pressure difference between the two ends of the tube and water starts to flow. Similarly, charges do not flow in a copper wire by themselves. For the flow of charges in a conducting metallic wire, there should be a difference in electric pressure across the terminals, which is known as the potential difference. Who creates this potential difference in a circuit? A cell or a battery creates a difference in potential across the terminals. The chemical action within the cell generates the potential difference across the terminals of the cell even when no current is drawn from it. Technically, we can define potential difference as the work done in moving a unit charge from one point to other point. When the cell is connected to a circuit, the potential difference sets the charges in motion in the conductor and produces an electric current. Current always flow from higher potential to lower potential. Now let's give a mathematical expression for potential difference. We learnt that potential difference is work done per unit charge. So, potential difference is equal to work done divided by charge. We use the letter capital V to represent potential difference. So, V is equal to W by Q. The SI unit of potential difference is a volt, named after Alessandro Volta, an Italian physicist. If 1 joule of work is done in moving 1 coulomb of electric charge from one point to the other point, then the potential difference between the 2 points is said to be 1 volt. So, 1 volt is equal to 1 joule per coulomb. The potential difference in a circuit can be measured by an instrument called voltmeter. Voltmeter is always connected parallel across the 2 points where the potential difference has to be measured. When you connect a voltmeter to the circuit, the positive marked terminal of voltmeter is connected to the positive terminal of the cell or battery because it has high resistance and hence it takes a negligible current from the circuit. The term volt gives rise to the word voltage. Voltage is the other name for potential difference. If a small positive test charge is placed in an electric field of a given charge, it experiences an electric force. If the test charge is moved from its position, then work has to be done against the electric force acting on it. Electric potential at a point in an electric field is defined as the work done in moving a unit positive test charge from infinity to that point. But in our common terms, we usually use potential difference. So come children, let's solve some numericals based on this topic. So the first question is, how much energy is given to each coulomb of charge passing through a 6 volt battery? Always start your word problem by writing down what is given in the question. Here, the potential of the battery, that is 6 volt, is given. So V is equal to 6 volt. You need to find how much energy is given to each coulomb of charge. That means the charge here is 1 coulomb. Now in your class 9, you have learned that energy is actually work done. So we have the formula V is equal to W by Q. From that, take the formula W is equal to V into Q. Substitute the values. Find the answer. The answer is 6 joules. The second question is, what is the potential difference between the terminals of a battery if 250 joules of work is required to transfer 20 coulombs of charge from one terminal of battery to the other terminal. So it's a direct question. Work is given, charge is given. You have to find the potential difference. Use the formula V is equal to W by Q. On substituting, you get the answer as 12.5 volts. So isn't it easy, children? Now, let me give you a homework question. How much work is done in moving a charge of 2 coulomb across a point having potential difference of 12 volt? Find out the answer and drop your answer in the comment box. I hope you have understood the concept of electric potential and potential difference. Thank you for watching the video. If you like the video, hit the like button, share the video among your friends and family, subscribe the channel, and don't forget to hit the bell icon that gives the notification of every video which is uploaded in this channel.